So in this problem, we have a pig sliding without friction down a semi-spherical dome. So since we're dealing with theta and r, let's resolve the forces in the radial direction. So to start off, let's draw an isolation diagram of the pig. So here's our pig. And we have the normal force acting in the positive radial direction, which we will define as radially outwards, and the force of gravity, which is mg, acting downwards. Now the angle between the radial vector and the force of gravity is theta, so the radial component of the force of gravity is just mg cosine theta in the negative radial direction. So by Newton's second law, we have that the net force in the radial direction is given by n minus mg cosine theta, and that is equal to m times the radial acceleration. So since the pig is moving in circular motion, its radial acceleration is just v squared over r in the negative radial direction. So we have negative mv squared over r. Now isolating for n, we have n is equal to mg cosine theta minus mv squared over r. Now we know what mg, theta, and r are, but we don't know what v is. Solving for v using kinematic equations would be difficult, so let's use energy considerations instead. So since the pig is sliding without friction, we know that energy is conserved. So the change in potential energy of the pig is equal to the change in its kinetic energy. So let's take the potential energy of the pig to be 0 at ground level, which means initially at the top of the dome, the potential energy of the pig, u0, is equal to mgr. And at an angle theta, its vertical position with respect to the ground is just r cosine theta. So its potential energy at angle theta is mg r cosine theta. Now, its final kinetic energy is half mv squared, and its initial kinetic energy is half mv0 squared, which means the change in its kinetic energy is just half mv squared minus half mv0 squared, and that's equal to the change in its potential energy, which is mgr minus mgr cosine theta, which we can write as mgr times 1 minus cosine theta. Now, if we isolate for v, we have that half mv squared is equal to half mv0 squared plus mgr times 1 minus cosine theta. So multiplied by 2 over m, we get that v squared is equal to v0 squared plus 2 gr times 1 minus cosine theta. So now plugging in that for v, for our expression for normal force, we have that n is equal to mg cosine theta minus m over r, all times v0 squared plus 2g r 1 minus cosine theta, and that simplifies to mg times 3 cosine theta minus 2 minus mv0 squared over r. Now, the pig leaves the dome when the normal force goes to 0, and in part A of the problem, we have that its initial speed, v0, is very small, so it's approximately 0, which means that the term mv0 squared over r disappears, leaving mg3 cosine theta minus 2. And we want to find theta such that this expression is equal to 0. So m and g are positive, which means that 3 cosine theta minus 2 is equal to 0. So cosine theta is equal to 2 over 3, which means that theta is equal to the inverse cosine of 2 over 3, which is approximately 48 degrees. Now in part B of the problem, V0 is finite, so our expression for n is mg times 3 cosine theta minus 2 minus mv0 squared over r, and that's equal to 0. So now we have mg times 3 cosine theta minus 2 is equal to mv squared, mv0 squared over r. So 3 cosine theta minus 2, or let's move that to the other side. 3 cosine theta is equal to v0 squared over gr plus 2, which means that cosine theta is equal to 1 over 3 times v0 squared over gr plus 2. So notice that cosine theta in part B is larger than cosine theta in part A, which means that theta must be smaller in part B than in part A. So let's make a note. Theta smaller in part B than in part A. Now in part C of the problem, we want the pig to leave the dome immediately at the top of the dome, which means that at theta equals 0, we want the normal force to disappear. So here we have our general expression for theta when the pig leaves the dome. So we want v0 squared such that cosine of 0, which is equal to 1, is equal to our expression for cosine theta, which is 1 over 3, times v0 squared over gr plus 2. Now, if you multiply by 3 and bring the 2 over, we have v0 squared over gr is equal to 1. So v0 squared is equal to gr, which means that v0 is equal to the square root of gr. So when v0 is the square root of gr, that's the minimum speed for which the pig will immediately fly off the dome.